All right, welcome to the demo recording for Sprint 3 of the Searchworks Indexing and Performance work cycle. I am Christina Harlow. I'm the product owner for this work cycle. And the team involved, we have Chris Beer, who is our technical lead. Shelley Doljack, Jessie Keck, Jack Reed, Camille and Drew Winget are our software engineers involved. Alyssa Hefele and Sarah Seastone are our key stakeholders. Gary Geisler and Jennifer Vine are involved as consultant UX designers. Stu Sneidman is our direct liaison or our manager, and Kam Chan is our ops liaison, sometimes with backup from Julian Morley. Today we're going to be going over what we've accomplished in the last week, which will be Sprint 3. In that week, we had the primary goals of getting prepared for a super users group review. We've had a couple previous demo work cycle videos or demo sprint videos that have shown the efforts we've made to be able to generate a relevancy delta report to send out to these super users and get them to review staging environments where we've done Solr updates that may affect the results returned. So we're actually getting prepared to send that out and get their feedback. We continued moving along on trying to trajectify our MARC and mods indexing pipelines, which will be the majority of what we demoed today, as that was the majority of the work of the last week. This means we're trying to take our MARC mapping logic and our mods mapping logic and use Traject, which is an open source library for doing Solr and expanded data mapping. We've also tried to unblock a couple different issues related to understanding what changes with regards to our searching as we upgrade Solr versions. In particular, there's been a lot of investigation into issues around CJK in the last week, and we'll show a little bit of the outcomes of that work. So with that said, I'm going to hand it off to Chris Beer. Or Jack, do you want to do the Traject? To Jack Reed. Do you want to share your screen, or is there anything I can share?
You could just...
I can pull up the project. That's what you're...
Sure, that's what I was thinking.
Cool. Then I'll share.
All right, so let me stop. Rad.
So this past week, the team has been looking at some of the CJK relevancy changes with our update to Solr. Stanford Libraries has had this library previously called CJK folding filter, which has been used. I think a lot of the significant development, original development was done by Naomi 5+ years ago. So over the past week, we've worked on enhancements to this to add an additional CAR filter that helps our CJK relevancy results remain similar and better to what we had but to this project, we've added a lot of changes and enhancements. We've updated the build to work in kind of like modern Java technology land, work with modern Javas 8 and 9. Also, it was previously only being tested on Solr 4. We've updated it to be tested with the more recent Solr 6X version, and added enhanced tests and test suites. We've also added some ways for adopters or users of this to quickly smoke test their CJK results, to try some queries quickly and get back results based off the code here. So this is a library that's used widely in the Solr community, for people who are doing CJK kind of searching, and so we've just enhanced it this week to add maintainability. Chris, want to talk about some of the changes?
So one of the things we noticed with our Searchworks relevancy going to this project was the approach we were taking before with CJK, and I can show it here, is given this 6-character... Okay, zoom in.
There we go, thank you.
Given this 6-character string of Chinese characters, we have a bunch of steps we run it through to try to normalize it and get it ready for users to search. This includes steps like taking traditional characters and turning them into their modern or simplified forms, which you can see especially in this last character where it changes fairly dramatically, or this middle one. And then ultimately we create unigrams and bigrams out of this set. So each character is represented as a unigram and then a bigram of the character before and after it. And through some cleverly tuned minimum must match settings, we were able to get some pretty good results for CJK within Searchworks. Unfortunately, with the upgrade to Solr 6, the approach we were taking was no longer successful. Solr made some changes to the way bigrams are treated in search relevancy that causes it to treat each bigram as more of an individual token, or sorry, less as an individual token and more as just a component of a word, which makes a lot of sense in a lot of use cases, but does not work for the way we were treating it for CJK. So we've had to make several changes to the way we do CJK query analysis. So here's the same query in Solr 6. I guess I need verbose output on. So the first change is the new character filter that Jack mentioned that we are injecting earlier in the pipeline. If you remember, in Solr 4, it happens about halfway through, but we discovered that it needed to happen earlier, and that required some custom development on our part to make that happen. The advantage of doing it earlier is then we can take advantage of the new ICU tokenization that uses dictionary-based word splitting for Chinese and Japanese, which, among other things, means we have more effective terms in our pipeline earlier. So this trigram at the end is treated as a single concept, whereas before it would just get split across multiple bigrams, unigrams, and if the user searched for a fragment of it, they would get less relevant results. So we're excited about the opportunities this may present for better precision, certainly in our queries.
Great, thank you. So the next thing we have is, do we want to add anything on the mods profiling now, or would it just do that later? Yeah, that makes more sense. So we're going to move into representing the trajectification of everything in our indexing pipelines. Again, this is the use of Traject. Chris, we have you to start with the mapping DSL. Cool.
So as we mentioned last week, we're starting to adapt our SolrMARC code for mapping MARC records into Solr documents to use Traject, which is a slightly newer framework in Ruby developed by some members and friends in the library community. And we are probably 95% of the way there. And we have a couple of basic patterns that I may show it in this file. It ranges from the fairly simple, like the ID field here. We have a simple extraction step that gets the value from the 001 control field and does a tiny little bit of munging to it, because in Symfony, these 001 fields have a prefix A. And for Searchworks, we want to strip that, so it's just a numeric identifier. A slightly more interesting example that uses logic from Traject is something like this titled uniform search field, which is a combination of repeating fields and their subfields. So in this example, this reads the title uniform search comes out of the 130 subfields A, D, F, G, etc. Joined by a white space character, or the 240 A, D, F, G, K, etc., joined by a white space character. So, and here we happen to take the first such occurrence. In other places, we'll take any or all occurrences of those fields and subfields. And we get a lot of, we get many of our trivial mappings using stuff in Traject, and it turns into these fairly readable one-liners in the mapping, which is great. Things start to get more complicated as we go through, where we have to build our own custom logic for things like combining across different types of fields. So we have an author title search that essentially takes the first author and combines it with either the first 240 or, sorry, the first 240 followed by any subfield or the 245A field, whichever one exists. So we don't have any of that logic that we get for free with Traject, but we can write fairly simple Ruby code in order to do that extraction. And from there, we have some of our more complicated logic in where are M holds. Here's an example of all of our format fun, where we map formats from 5 or 6 different places, and we simply repeat our 2 field for each of those permutations, which cleans up the code considerably from what it was, where it was a large series of nested if statements. So we're happy with the readability improvement here, even if the logic is still fairly complicated.
And while you're looking for the holdings logic, I would note that one of the reasons we really looked at Traject for a lot of these ETL type applications is that it has this DSL for mapping, so that we can more readily hand it to our metadata or other colleagues, and you don't have to be a Java or Ruby scholar to understand. You can see to this field, from that field, apply some magic, but the mapping there is very explicit in one file.
And that holds true for a huge number of these mappings. There's probably 5 or 10% that start to get into some hairy Ruby logic, including this mhold display field, which is extracted from about 6 different 800 fields, depending on their subfields, what values are in those subfields, and every time an 852 appears, it creates a new mhold display value. So we've ended up having to write quite a bit of code in order to accomplish this. Even so, the nice thing about Traject here is the extraction logic is up front and center, so we know at least what fields it comes from, even if the logic after you collect that data is a little hairy.
Great, thank you for walking through that. Now we're going to just go through a couple members of the team who really dug into this, because like I said, this was a very large effort over the last week. Jessie, do you feel like showing a little bit first on call numbers?
Do you want to just show?
I can jump up there if you want.
Yeah, so one of the things that I worked in a bunch today was, or sorry, not today, this past sprint, was dealing with some of the call number logic. So primarily, we have a field that allows us to do call number search, and then what we're which is relatively straightforward, just dump call numbers that shouldn't be skipped into a field for searching. So not super interesting, but what we have here is the call number facet, which in Searchworks manifests itself in the hierarchical facet. So where up front you have 3 values: Library of Congress, government document, and Dewey classification. And then you can kind of drill down into the various groupings of those classifications. So in this logic here, where we started pulling out a little bit of a class that says CRC holding, which basically kind of just models a 999 MARC field. So we're doing the extract in the config here, but passing that into the object, and that gives us some of these accessors that you can see, like we don't want to process it if it's skipped. And these are all ports from accessors that were in the previous Java code. So there was a notion of a skipped holding, or asking if it was Dewey or a valid LC, or as you can see here, lost or missing, ignored call number. So these were all concepts in the Java code that were ported over, but at least now are, as we're looking at this configuration, it reads a little bit more sensically, at least might be able to, as you can see, we're saying, okay, like, don't do this thing if it has a bad LC call number or if it's shelled by location. And then once we do that, we'll kind of go through and start doing some more complicated logic about what kind of call number, based on the kind of call number it is, trying to parse out pieces of the call number and then mapping that over to what the classifications are to be able to generate that drill down facet for the subject headings. And so that one of the things that we've done here is in the original code we kind of had one function that would branch between if it was a Dewey, if it was an LC, or if it was a government document. But what we do in our configuration is a little bit more explicit, and then we have explicitly 3 two-field branches where we call num facet, and then we just do one for LC, one for government document, and one for Dewey. So that the logic between them, which are different, how we parse out those call numbers and define those mappings, is in completely separate parts of the configuration, as opposed to kind of all jumbled in a nested if statement in some Java. So a little bit more declarative here.
Great, thank you. All right, Camille, would you like to share your screen? Or?
Yeah, thank you. So Traject also offers us some niceties around translation maps. We were able to take our library map and location reserves list straight from our SolrMARC code base and just pop them here into this Traject indexer. So here we have an example of building facet where we need to refer to multiple subfields, compare them against our reserves list, and then pass them through a translation map so that instead of the library codes, we get nice user-friendly strings. So,
great. Well, thank you for showing that. Translation maps are extremely helpful to have. And Jack, do you want to talk about course reserves and deletes?
So one thing that part of this week's work was looking at the way our course reserves indexing works and also our delete indexing. Currently we manage course reserves indexing from a different code base that then changes values in the Solr field for that document. So we were able to actually port most of that logic into our Traject config and take a 1400 line code base down into 70 lines of Traject code plus tests, which is really exciting to have. We don't have the full course reserves yet because course reserves make some logic changes based off item display, and item display is pending still, but we're very close on that. So it's nice to have everything in kind of one place. Also, we were able to do the same thing with deletes, where we kind of had some custom code to do deletes before. Now we take the same type of deletes file in, and we can process deletes to the index in a similar way as we did before. So all that kind of brings together kind of these other pieces and also into the same code base, into the same processing pipeline that can be used together in concert.
Great, thank you. Okay, and then so this has been all focused on MARC. We want to make sure that we do mention what's going on with mods. Chris, you feel okay to take that on?
So as we showed last week, we've also made progress on our mods mapping using the same Traject framework to do both. Whereas currently our MARC mappings are managed in a Java project based on SolrMARC, and our mods mappings out of SDR are managed in a separate Ruby project. With this new rewrite, we've been able to combine them into the same code base, which is extremely helpful to see how the same fields get mapped from different places. The good news about the mods is we're able to take advantage of existing semantic mappings that we were using before, and we're able to continue using them within Traject, using this Stanford mods gem that we've created here to do that for us. So we can see mapping Stanford mods from our Searchworks short title field, or an authored field out of the main author in mods. So this reads less explicitly than the MARC, where it was clear what fields it was coming out of, but it's able to use the same framework, which is an exciting development.
And do we want to add anything on the mods profiling or move into the verifying?
Sure, I can say a quick thing. And with this mods indexing work, we've compared it against our current indexing pipeline, which was able to sustain 2.5 records a second. Currently, without any particular optimization in Traject, we're seeing 1.6 records a second. So we're a little slower, but there's some obvious room for improvement, especially with all the network lookups for things like collection and set titles that happen in this code. And we should compare that to the MARC record speed, which I believe is several hundred records a second in Traject.
Oh. Look it up.
But that's okay. We know that mods is something that we're going to try to do some tuning on as well. Network calls, and then we're dealing with big old XML documents instead of binary. So, and then as we're switching over all of these mappings to Traject and Trajectification, we have done work this past week to make sure that the mappings are indeed the same across both code bases. Is there anything that the team would like to mention with regards to that?
I can pull up our Travis report.
550 a second.
So 550 MARC records a second?
Yeah, but running in one process.
So one of our test suite additions this week is the addition of 50 integration tests that compare the output from Traject against its equivalent output from SolrMARC. While we're not complete with our MARC mappings, we're missing about 4 fields. For the most part, our mappings are very close to what was coming out of SolrMARC, and we've created tickets for where there some variation. An example of variation here is an author sort field that happens to have a little extra white space in our Traject code compared to the equivalent code from SolrMARC. Similarly, there are questions around trailing punctuation, stripping, or another good example. Or a series search where we're now retrieving more data than we were before. And so the team has to do some analysis on these variations, and we expect to resolve them. Again, it's fairly minor, which is exciting to see, and we now have tests that are going to help us prove that.
Great. And just a reminder of that, we're not actually trying to touch the mapping, so this is to confirm that the ported over code does the exact same thing, not that we're trying to enhance it.
And one thing we've discovered through this process is some potential bugs in the way the current Solr indexing works, including around title punctuation stripping and around call numbers and shelf keys. And we're going to attempt to preserve the current behavior, but make tickets for the future to address these potential issues that we've discovered.
Yeah, for sure. Great, thank you, Chris, and the rest of the team. Is there ops reporting that we would like to do?
Sure. I'll mention a few things.
Okay. Do you want to share anything?
No.
Or? Okay, cool.
So this past week, assigned several Solr RPMs that Chris created into our library repo, and also there was some space issues on one of the Solr nodes. So I went ahead and added this to all A through F Solr nodes and expanded them by about 2 times. So hopefully that'll be enough for future test.
Great.
That's it.
Well, we always like expanding Solr Node.
Yeah.
So thank you for watching this demo video for Sprint 3. Hopefully in the next sprint, we're going to be starting with some outstanding work from other external projects and then returning to this and keeping along the lines of figuring out where we want to use this Traject pipeline, how it gets triggered, and actually start turning into how do we improve the performance on the Searchworks application side. If you have questions, comments, or issues, you can leave comments in the video below or follow up in any of the communication methods in the description of this video.